The Doomsday Argument, also known as the Carter catastrophe, is a thought-provoking theory that attempts to predict the future human population based on the number of humans born thus far. Astrophysicist Brandon Carter first introduced this concept in 1983, with philosopher John A. Leslie, J. Richard Gott, and Holger Beck Nielsen later independently discovering it. The Lindy effect and Heinz von Forster also suggest similar eschatological principles. The argument suggests that if the total number of humans that will ever live is fixed, then the probability of a person existing at any given time in history is proportional to the total population at that time. Therefore, one's existence can provide insight into the total number of humans that will ever live. The Copernican principle states that any one human is equally likely to exist, and it is statistically estimated that the total number of humans that will ever live is unlikely to exceed 12 trillion. Based on this theory, it is suggested that the remaining 1140 billion humans will be born in 9120 years, assuming a stabilized world population of 10 billion and an average life expectancy of 80 years. By calculating the probabilities for each value of n, a statistical confidence limit on n can be ascertained, implying that it is 99% certain that n is smaller than 6,000 billion. The Doomsday Argument does not predict a definite end to humanity or provide a limit to the number of humans that will exist. Instead, it states that there is a 95% chance of human extinction within 9,120 years and a 5% chance that some humans will survive beyond that. This argument has sparked a philosophical debate with no consensus yet. The argument is based on a prior distribution of the number of people who will ever be born and uses Bayesian inference to calculate the probability of n humans being born if n is a random draw from n. The use of a vague prior distribution is well motivated as it assumes as little knowledge as possible. Gott's original paper used the number of years humans had existed as a species as the reference class and gave a 95% confidence interval between a minimum and maximum survival time, with a 97.5% confidence that extinction occurs before the upper boundary of his interval. The integral for the probability of n less than or equal to z can be calculated with n as 200,000 years and z as 40n. The theme of the story centers around different arguments surrounding the Doomsday Argument. Gott's argument is based on a 95% confidence that human extinction will occur between 5,100 to 7.8 million years in the future, which he has tested against the Berlin Wall and Broadway and off-Broadway plays. Leslie's argument, on the other hand, focuses on the probability shift resulting from considering one's birth position, rather than assuming a vague prior probability distribution. Von Forster argued against the notion that humanity's abilities to construct societies and technologies results in self-inhibition, and predicted that the population would reach a mathematical singularity by November 13, 2026. The reference class, from which n is drawn and of which n is the ultimate size, is a crucial point of contention in the Doomsday Argument. Bostrom's self-sampling assumption suggests applying the standard Doomsday Argument to observer moments instead of just observers. The Doomsday Argument proposes that humanity has a limited time left before extinction. However, some critics find fault in its extinction time estimate and question why the observer cannot be assumed to be randomly selected from the set of all humans to be born. They argue that this set is not an appropriate reference class and imply that the observer is within the first 5% of humans to be born. This argument can be refuted if one has measurable attributes that set them apart from the typical long-run user. Robin Hansen's paper summarizes these criticisms and rejects the idea that our knowledge of history or ability to prevent disaster produces a prior marginal for n with a minimum value in the trillions. Critics argue that this response overlooks the technological threats to humanity's survival, to which earlier life was not subject. However, most academic critics of the Doomsday Argument reject this response. The story's theme centers around the Doomsday Argument and its objections, with a focus on the self-indication assumption objection. The author discusses the impact of Q on the upper bound of the uniform draw and notes that flattening the distribution from a vague prior could be done by allowing the probability to fall off more slowly with n, suggesting that humanity's growth may be exponential. The author goes on to explain how the inference of n from n can be produced with the principle of indifference and describes how the chance of a trillion births can be well over 20% with certain assumptions. The author also explores objections to the Doomsday Argument, including the possibility of not existing at all and the incompatibility of the uniform distribution assumption with the Copernican principle. Upon inquiring about the age of the woman celebrating her 50th birthday, it is determined that with 95% confidence, she will survive anywhere from 1.28 years to 1,950 years into the future. Although this may seem like a wide range, it becomes concerning when Gott's rule predicts that with a half probability, she will surpass 100 years old, and with a 1/3 probability, she will surpass 150 years old. This highlights a weakness in Gott's Copernicus method, as it does not indicate when it can be applied. However, philosophers such as Nick Bostrom refined Gott's argument by specifying that the absolute birth rank, n, must give no information on the total population, n. In a comparable birthday party example, the lady's age must be hidden prior to estimating her survival time. The DA reasoning produces a rule to convert the birthday, n, into a maximum lifespan with 50% confidence, n, but this can only be accurately determined 50% of the time. The Doomsday Argument may create a paradox, as those who contemplate it may no longer belong in the reference class human. The Doomsday Argument has attracted much criticism from various authors who argue that it is based on a flawed assumption that confuses future duration with total duration. The argument relies on the idea of doom soon and doom deferred, which occur after the observed value of the birth order. Pisaturo and O'Neill both argue that the equation used in the argument conflates future duration and total duration, making it an invalid application of Bayes' theorem. Gelman and Roberts suggest that the argument confuses frequentist confidence intervals with Bayesian credible intervals. In conclusion, the Doomsday Argument's claim that there is a Bayesian shift in favor of a shorter future duration is fallacious and based on flawed assumptions that need to be reconsidered.